So in the last lesson, we spent a lot of time practicing using the quadratic formula when we had a quadratic equation in standard form. So let's just write up that again, just so we have some sense of remembering what happened in the last lesson. And most of the time when we had an equation, we basically, this is the standard form in variables, but normally it looks something like this. Like, I'm just making one up now. And what we did in the last lesson is we used this quadratic formula to help us solve for the roots or the solutions to this equation. If there are solutions, they don't always have solutions. And one of the things that we worked with was we realized that sometimes it's quicker to write the quadratic formula, not always, and you don't have to follow my method, but sometimes it's quicker to think about this thing inside the square root bracket as something called delta. And then what we did some of the time was we worked out this delta thing first, or sometimes it's called the discriminant, and then we use the formula to get the roots. And I mean, I just made up this quadratic now, so I don't know if it has a solution. It may have no solution, but I want you to just start by working out delta for this particular quadratic equation. So take this quadratic, and we can see that the A is here, the B is here, the C is here. What is delta going to be equal to for this particular quadratic equation? And once you've worked it out, you can pop your answer in the chat. Mm-hmm. We have Okay, so we haven't got the answers to this quadratic equation yet, but what we do have is we have the value of delta. And so using delta, we can now find two answers to this quadratic equation. If delta had been negative, so if delta was a negative number, there would have been no solution. But because delta is a positive number, or if it had been zero, it would have also worked, we can now go and find the solutions. And the way we did that was we said, well, x is equal to, in fact, let me let you try and do that. I want you now to take this thing called delta, and I want you to find me the two solutions to this quadratic equation. And you can use this. Yeah, let's go to, is it Rye? Can we unmute Rye?
Their audio is not connected, Mr. Yes.
Aha.
I'll DM them.
So what I've done in the interim is I've written out kind of what the solution would look like that. And now we need to get to our two answers. Now, the good news is the first one is going to be -4 plus square root 4. And then this is going to be over 6. And let me actually do the other one at the same time. -4 plus 2, and then it's going to be -4 minus 2 over 6. So x is going to be -2 over 6, or minus a third. Or x is going to be -6 over 6 equals -1. Now, you don't have to do every single step that I've done. A lot of you will be able to go in less steps, but I wanted to show you the process of using delta, then writing out kind of the answer all put together in one place. So let me just highlight where that is on the screen. So this is kind of the step that came after delta, where I wrote all the answers, but they together. And then I split them apart so you could basically see the final answers. And so that's a process that's going to happen many times today. And I just want to check in, are there any questions about this process? This is what we spent a lot of the last lesson for our new students. You'll see that we spent the whole of the last lesson practicing this. Just make sure I haven't made any silly mistakes. You have -4. The mistake that I would imagine some students make is they don't write the b correct. So if you look here, this is a minus b. And so this should be -4 when I do it. That could have caught a couple of people out. The other thing that can catch people out is that when you square root 4, you get the +2 one over here, but you also get the -2. Okay. Give me a thumbs up if you're okay, if things are looking good. Thumbs down if you... Okay, some of you are saying finding delta separately is a bit confusing. Now, you don't, like I said, if you get the right answer, you don't have to do it like this. But the reason I do it like this is it helps students understand there's a section called nature of the roots, where if you find delta, you can tell stuff about the solution to the equation. And a lot of students don't really know why delta is important. And by doing it like this, you can see that delta is sitting inside of the quadratic formula. But you can choose whatever way you like to do it. Okay. For those who are still feeling unsure, don't worry. Lots of time to practice. We're going to move on to the second example. I'm going to do one for you now, and then we're going to keep practicing. So what is the main topic for today? We are going to learn how to solve quadratic simultaneous equations. So what does that mean? Well, I think the best way to do it is for me to show you. So if you look at these two equations, the one looks different to the other. I'd like to know, can someone tell me what it means to solve something simultaneously? And I also want to know from people in the class, what is different between the pink one and the green equation? So let's start with a bit of a chat. Can we unmute? I thought I saw a hand go up. Orikonisa, would you like to give us some thoughts?
Hi, sir.
Hey.
I would like to answer the question which says, what is a simultaneous equation? What does it mean?
Yeah. What does it mean? Yes, I want to know.
I think it means we're going to solve to find in the points of intersection. Yeah, of graphs. Yes.
Right. Perfect. So Orikonisa is making a good point. The pink equation has a graph, and the green equation has its own graph, and where they meet will be the solution to this simultaneous equation. Another way of saying it is that we need a value. Okay, so when we say solve simultaneously, we need a value for x and we need a value for y that will satisfy both these equations at the same time. So like if we put x and y into equation number, the pink one, and then we put x and y into the green one, they have to make both statements true. So that's what it means to solve simultaneously. So let's see how this works in practice. I'm going to show you how it works. The method I'm going to use now is called substitution. And what we do is we look for the easier of the two equations. And I want to know in the chat, which is the easier one, the green or the pink? Oh, and Owama said the pink one is a quadratic and the green one is a linear one. Okay. So maybe actually the question that I can see in the chat now, there's actually a mixed opinion. Some people are saying pink, some people are saying green. Even though the layout of the pink one is easier, the pink one is a quadratic. It gives you the shape of a parabola. And the green one is a straight line graph. And I think, even though it looks a little bit messy, that the green one is the easier of the two. And so what I'm going to start with is I'm going to start by working with the green one. And I'm going to make y the subject of the formula. And I get y equals 2x plus 1. So this is related to the green one. And this is what's called making one of the variables the subject of the formula. So step one is that. Umta, let's go to you. What's your question?
Afternoon, sir.
Hey.
How are you?
Very good. How are you doing?
I'm also good, sir. So may I please ask, how do you know which one is, how do you identify the quadratic and the linear?
Okay, so good question again. The power of 2 that is in the pink one tells you it's a quadratic equation. And if you had to draw it, it's either going to be a happy face or an unhappy face. So parabolas generally look like
or a
this.
hyperbola?
It's not a hyperbola. We'll get to hyperbolas when we talk about functions, and I've got a hyperbola later on today. And then this is a straight line over here. Yeah, Ntando, what's your question? Let's go to you. Hey.
Is it possible to solve the green one by using the completing process?
Okay, when you deal with solving simultaneously, we do not use completing the square. So let me even take a moment to clarify. When we solve a quadratic equation, at the moment, the pink one is a quadratic equation, but it's got 2 variables. We can't solve it. We have to first do something. We have to eliminate one of the variables, which I'm going to show you now. But even when I want to kind of make a point about when we're solving quadratics, what should be the order that we use the tools in? Generally speaking, when you solve a quadratic, your Swiss Army knife, the tool that you use the most is the quadratic formula. It's the most reliable. So generally, I will default to that unless the quadratic equation looks very easy to factorize. We only ever use completing the square if they ask us to use it, because it's much harder to carry out. Okay, so I'll get you in a moment, hearties. I just want to do this first step. So the first step is making the y the subject of the formula. Then I sub it into the pink one. And what I'm going to get is I'm replacing this y with the y over here. And so I get 2x plus 1 equals x squared minus 2. So from that point, I want to see how many of you can solve this quadratic equation. I want to give you a little bit of time. Now that I've done the step 1 where I've eliminated the variable, see if you can find what the solution to this quadratic equation is. And then if you're stuck or you're like, this looks different, or maybe you're a new student today, maybe pop your hand up and we can chat while the rest of us give it a go. Yeah, let's go to Juliet.
Hi,
Juliet.
sir.
Hey. What
Sir,
can I help
can
you?
I please ask how do you eliminate the y?
Okay. So good question, Juliet. So Juliet, if you look at the beginning, there's a y in the green one and there's a y in the pink one. And what I did was I said I chose to work with the green one because it's a linear, or it doesn't have like little, basically it looks the simplest. It's a linear equation. So I chose to make the y stand by itself by moving the minus 2x across And now y is, I say like in class, I often say the y is lonely, right? It's all by itself. Now, because it's by itself, I know exactly what y is. It's 2x plus 1. I can put this y into this y over here. So I replace that y with 2x plus 1. And now I've eliminated the y's because there's only x's left. Does that help, Juliet?
Okay, I get it now.
Perfect. Thank you for your question. I think you helped a lot of students there. So the next step that I was going to do is I was going to move everything to one side. And I should get that. And then at this point, you have a choice between finding either using factorizing or you can use the formula. I don't mind. I think this one looks like it could factorize quite easily using that method I showed in lesson 1 and 2, but the formula will still work. And so I'm going to use the formula for now just because it's what we've been using lately. Capano, let's go to you. What's your question?
Afternoon, sir.
Hey.
So I actually want to understand, why are we solving simultaneously, but yet we're using the quadratic equation? I don't understand the link between those two things.
Those two ideas.
Yes, sir.
Okay, again, you're asking such good questions today. So when we say solve two equations simultaneously, what we mean is if we had a graphical picture, where the two graphs, where the pink and the green graph meet. So that's the visual interpretation. But in terms of algebra, we're saying what x and y value will make both the pink equation and the green equation true at the same time. So that's what we're trying to find. So say I make a claim, right? Let's say I make a claim and I say x is 0 and x is 1. Now I'm lying, but I'm lying on purpose. Because if I look at the pink equation, if I put 0 for x and I take away 2, that's not equal to 1.
Yes.
So I'm looking for an x and y combination. Sorry, that was actually, I did something a little wrong there because I made two x's. I should have had an x and a y. But you get the idea. I'm looking for an x and y that make these both true. So let's go and find the answer. Some of you will have used the formula. To speed things up, I'm going to use factorizing here. So let's go minus 1. But my formula people should get the same answer as me. So then we get x is 3 and x is well, we can even split it. Let's do this. Trying to go too fast, yeah. So we should get x is 3 or x is minus 1. Now that is not the solution completely yet. What this is just the first part. We found the x's for our simultaneous solution, but we still need to get the matching y's. Can anybody suggest how we get the y's that go with this? Orikanisa, I'm going to come to you. Or Sipakazi, let's go to you.
Hi, sir.
Hey.
So basically we're going to substitute the x values into the equation that we've got, which is y equals to 2x plus 1 to get the y values.
Perfect. So we're going to use this one up here. And if we go y 2 times something plus 1, if we put a 3 in there, we should get that y is 7. So if x is 3, y is 7. And if x wasn't 3, if x was rather minus 1, 2 times minus 1 is minus 2, plus 1 is minus 1. So what does that mean? It means that the one solution to this equation, or the intersection point, is, let me do it up here. The intersection point is 3, 7, or it can also be -1, if they ask for an intersection point. If they ask for the simultaneous solution of x and y, you can just say x is 3, y is 7, x is -1, y is -1. Okay, let's go to Chuma.
Sir.
Hey.
Sir.
How's it going?
So, sir, I wanna ask, like, by the x squared plus 1 is equal to x squared minus 2, did you like add the x squared plus 1, or how did you get that -3 there?
X squared. So how did I get, oh, this
The
part over here?
-3. Yes.
Okay. I should have probably used the formula because that's what I've been doing mostly. I could see that it could factorize. So I'm going to slow down for a second. Would it be helpful if I got to the solutions using the formula? Chuma?
Yes,
the
sir,
formula
I
that okay. Let me do that because I think a lot of students, that's what the question will be about. So let's do that. So if we think about the quadratic formula, we said that it looked like that. And so what I'm going to do is I'm first going to find my delta, which is this thing inside, or b squared minus 4ac. And that is going to look like this. So a is 1, b is -2, so I go -2, a is 1, and this is -3. And then find what delta is. So let's go. That's 4, and that is plus 12, so we get 16. We're not done. Now we actually still have to get the roots of the equation. So we go x is equal to minus b, so -2, plus minus the square root of 16 over 2 times 1. So then, if you think about it, we're going to get x is 2 plus, what's the square root of 16? It's going to be 4 over 2, or x is going to be 2 minus 4 over 2, and that's going to give us 3, and this is going to give us -2 over 2, which is the same as -1. And good news for me, the maths teacher, is that the 3 that I get over here and the -1 I get over here is the same as what I got when I used the other method. Now, in order to get the y values, I would do the same thing that I did before, where I took I know there's a lot going on the screen, so I'm going to slow down and we're going to have a break in a second. But basically, I take these pink values and I just put them in here. So there's the -1. It's almost like coming from here. And that's how I get the matching y values. Okay, let me go to questions from the class. Are there any questions? Can we unmute? For some reason, I've lost my bar where I can see what's going on. So maybe we can unmute.
I'll unmute Juliet.
Thanks.
Sir,
Yes.
isn't we wanted to find the y,
Yes.
the answer for y, and we say 2 times -1 plus 1, which is equal to -1. Why
Yep.
didn't we do the same thing with egg, with the 3?
Okay, we do. So the thing that goes with 3 is going to be 7. The thing that goes with -1 is going to be -1. So let me show you. So if you look here, let's take 3 and put it here. What do we get when we go 2 times 3 plus 1?
2 times 3, 6.
Can you see that
plus
I get?
1. Yes.
Would you agree it's 7? And so that's the 7 that we have down here.
Okay, thank you.
Pleasure. Guys, you've done so well. what I want to do is I'll answer one more question, and then we need to take a break so that we can give us our brains a chance to just relax, and then we can come back in the second part of the session to practice more. So let's go to the next question. Who's the next question from?
Hi, sir.
Hey, how can I help?
So what I wanted to say is that to make it easy is just that you're going to write from the question, you're just going to write equation 1, a circle, and write a 1. Then from the second one, you're going to write a 2, and then you're going to say from equation 2, y equals to 2x plus 1, and then we're going to make that equation 3. So it's simpler, and then you just say substitute 3 into 1, and then you make them in the, so that it doesn't confuse people.
Okay, I love this idea. And so I'm going to just, before we go and have a break, I want to have a quick little example of this, what's going on. And then we'll come back to this question after the break, and we will have a look at it. So what has been suggested is we should nominate one of the equations as equation number 1 and one of the equations as equation number 2. Now, and then, so if we say that, if I look at these two, I think that I would call this one over here equation number 1 because it looks simpler. And then this one over here is going to be equation number 2. And then, like we said, we're going to take equation 1 and substitute it into equation number 2. So that's what we're going to do after the break. But because our brains have been working hard, and for those students who are feeling a bit lost, trust me, by the end of the lesson, it will all be clear. But we need to make an investment in ourselves now and just do a bit of stretching. So if we could all have everybody on their feet, and we're just going to stand up for a second, and we are just going to stretch because you've got to take care of the important stuff upstairs. So stand on your feet, and I want to see Mkosini, Laseri, Gift, Onati, Nokozolo, Luyanda, Annie. Let's do this. Okay, guys, I'm feeling some jumping jacks. Like COVID is behind me. I want to use my body. So the way jumping jacks go is we clap on the top and we come down. So we go 1, 2. Just give me 10. Ugh.
Come on, guys, put on your jackets.
Come on. I'll get the old guy beat you. Love it. Love it. You bring me great joy. I love that my students are participating. I love that we don't have to take things so seriously that we can't be a little silly. You know what I mean? Life is too short to be serious all the time. You're being very responsible by being here and working hard, but it doesn't mean we can't have some fun. Okay, let's, my heart rate is somewhat raised, which was the point. But let's us go to the second part. So we did the stretching. Now, the second thing today is we're going to do something called Math 24 quickly. And I want to see, can you find 24? Let's just do the red one. So you have to use all the numbers once, and you have to try and make 24. You can only use plus, minus, times, divide, and brackets. Can you make 24 using those 4 numbers? That's what I want to see. And then you can put your answers in the chat. So we have to use each of the numbers once. And we can only use plus, minus, times, divide, and brackets. So, Bonnie, you are close, but you have to use every number, and you've only used 3 numbers. So you've said 7 times, wait, no, have you? You've used, okay, so I was thinking, okay, Mafonise, let's go to you. Yeah. Mafonise, can you hear me? We're asking you to unmute there.
Say, I still don't understand what you guys are doing.
Okay, no problem. I didn't really explain it very much. So this game is called Math 24, and we're trying to use each of the we're trying to use all 4 numbers to get to 24. And so I'll give a hint here. I think 7 minus 1, which would use up these 2, gets me to 6. How do I use these last 2 numbers to help me get to 24? That's the hint. Does that make a bit more sense, Mofanise?
Yes.
Perfect. Perfect. Hearties, what do you think?
You multiply 6 by 4 and then multiply again by 1.
Yep, you've got it. So 1 doesn't really, you can do anything you like with 1 as long as you don't add it. You can divide by 1 times by 1. So 6 times 4 times 1 gives you 24. Okay. So this is one of I used to play this game when a lot, and it really helped me with my times tables back in the day, once upon a time. Won't say when. But yeah, it's a good game for just getting those computations automated. All right,
Nice
everyone.
one, guys.
Very happy with this class. It's time for us to do another simultaneous equation. So based on our class, we've decided that calling the one equation, equation 1, the other one, equation 2, we're going to sub the easy one into the harder equation and see if you can solve that for me. So if you have a question, feel free to put it in the chat or raise your hand. Otherwise, yeah, just keep working. And when you've got your answer, you can pop it in the chat. Let's go to Mafonise, maybe. Yeah.
So doesn't the 8 change the equation to negative?
So are you happy that this becomes a negative because it goes across?
Yes.
And then this becomes a negative because it goes across. So my next step was going to be to write this in standard form. -7 plus 8, that gives me a +1.
Oh, yeah.
Okay. But now from there, there's still quite a bit of work to do. So, okay, so for those students who, oh, let me keep going to the questions, but for those who are struggling, think about the steps that we're doing. Juliet, what's your question?
So, sir, is this solving for the first equation or the second equation?
Okay, so we're solving simultaneously. So it's important for me to clarify, because I didn't actually put the words here. The words would normally be solve for X and Y simultaneously. And the simultaneously means you need to have two things that you're solving for. And the two things that we're trying to solve at the same time, I'll call it the green one, which is the linear equation, or equation one. And then the second one, which is the quadratic equation, or the parabola. And what we did was we subbed equation one into equation two by replacing this y here. And our goal at the end of this is to have x equals something and y equals something. We'll probably have two of each, and those will satisfy both of the green and the pink one at the same time. Or another way of saying that is it satisfies it simultaneously at the same time.
Okay.
So that's where we're going. But in order to get there, we have to take these steps. Step one was substitution. Step two was get its standard form. And now we have a problem that feels a bit like the last lesson, where we have to solve this equation in order to solve the bigger one. So let's, oh, what happened there? So you can solve this using the quadratic formula. It may factorize. I don't mind. I'll stick with the quadratic formula for now. You are always given the quadratic formula. Oh, I get delta is 1. And then my answers are going to be minus. Okay, so I get, and I know there's quite a bit of work, but the good news is a question like this would be worth a good decent amount of marks. I get x is 1 and y is, x is 1 and x is a half. But now that isn't the question finished yet. I want to know, what do we do next? Which student will be willing to share their thinking? What is the next step in trying to solve this simultaneously? Would anybody be willing to share? Kumo, let's go to you. Or did we lose Kumo there? Maybe we can go to
I think we lost Kumo, yes.
Oh, there's Kumo.
Good day, sir.
Yep.
So since we use equation 2 to solve for x, I think we're gonna use the first equation to solve for y.
I totally agree.
Yes, sir. So
and what would you do?
we will use the answers we got for x and simplify them for the equation 1.
Perfect.
So
I loved how you referred to equation 1 there, the green one. You're saying I must use the green one.
yes, sir.
Okay, what do you get if x is 1? What is the y value that goes with that?
The y value will be 10.
I completely agree with you. And for the second one, what did you get for the second y value?
I got 17/2.
Okay, let me see if I can match you on that. For the moment, my mouse won't move. Come on, mouse. Let's see if I agree. So I would take the half plus 7. And so then I could use my calculator, 3/2 plus 7. I get 8.5. Did you get 8.5? Are you following me with that? So, okay, so I think a couple of people might have lost 17/2 is 18.5. Sorry, 17/2 is the same as 8.5. So my answers are, you can see them here. When x is 1, y is going to be 10. And when x is a half, y is going to be 17/2 or 8.5. Now, what we mean for simultaneous solutions, I want you to try this. If you take 1 and 10, if I put 1 and 10 into the green equation, does it make it true? Well, let's see. 3 times 1, 3 plus 7 is 10. Yeah. So if I sub it into the green one, it works. But now the test of being simultaneous is, does it also work for the pink one? So let's try that. 1 squared is 1. 2 times 1 is 2. 2 plus 8 is 10. So it simultaneously satisfies both the green and the pink, or the equation 1 and equation 2. And that's what it means to solve an equation simultaneously. The other one will also work. I'm just not going to spend the time doing it now. I want to use the remaining time for questions about what we've done here. So let's go to Afika. Can we unmute Afika?
Afternoon, sir.
Hey, how can I help?
So I need you to explain the formula. I can't understand it.
Okay. So when we're solving the form with the formula, I'm using a form where I have that little triangle inside it to make it, writing it out a bit simpler. However, the full formula is also written as minus b plus or minus b squared minus 4ac over 2a, which is quite a mouthful. Okay. Now, what you can do is, if you want, you can put everything in one go. Okay, so if you do it like this, you'd go minus, if I look at this equation, I go minus 3 plus minus minus 3 squared minus 4 times 2 times 1 over 2 times 2. So that would be some people do it like that. And then once they've got that, they simplify that down. This thing inside here, we've worked it out already. It's delta. It will be 1. And then this would be 4. Are you with me so far?
Yes, sir.
And so now x is going to be equal to 3 plus 1 over 4, or x could be equal to 3 minus 1 over 4, because the square root of 1 is just 1. So you can also do it like that. My worry, though, is that sometimes, and it's not wrong, if you feel comfortable doing it like that and you can do it, do it. But students sometimes get a bit confused about what's going on inside here. And when they type it into their calculators, they can make silly mistakes where if they work out delta separately, it means that normally they get a mark for that, or at least partially. And then when they type it in their calculators, it's not as difficult. But again, everyone's different. So I'm not going to say what you must do it. I'm just suggesting what I think is useful.
Thank you, sir.
Okay. Are there any other questions? Or are we ready to put the link? I think, Lebo, could you put the link to today's quiz? And then I will take one more question or maybe two more questions. But everyone, it's been lovely teaching you today. I do hope if you feel a bit overwhelmed, don't put too much pressure on yourself, especially if you're new, because you've come in the 6th lesson of a series. The goal with Watobe is to just keep adding a bunch of knowledge every week. And then as you have time, watch some of the old videos that we've done. And gradually over time, like fitness, you just get better at something from practicing. And hopefully you have a bit of fun along the way. And that'll also help you in wanting to practice more. Okay, who do we have with questions?
We have Letabo.
Let's go to Letabo. How can I help?
Hello, sir. Can you hear me?
Loud and clear.
I wanted to ask about the second equation for y.
Okay.
Why is it? Yeah. So I'm not getting 8 or 1 over 2.
Okay.
So.
I think I know why. So I want you to focus on the pink highlight blocks that I'm doing at the moment.
Yes, sir.
Can you see that I've got the equation 3 open bracket plus 7? Now this comes from up here, equation 1. And I'm subbing in the value a half. Now that half comes from here. So I'm putting a half. Now 3 times a half is actually 3 over 2, and that will catch people.
Yes. Sir.
And 3 over 2 is 1.5. So 1.5 plus 7 is going to be 8.5.
Oh, thank you, sir.
Pleasure. All right, everyone. For those who had a disrupted, some people were saying that their feed was disrupted today. What I want to suggest is by tomorrow afternoon, the recording will be out, and just go and watch those little bits that you missed out on. I am going to close the session for tonight because I think we've done a lot, and I think it's time for your brains to consolidate. And in Corsi, how do we go about solving the sum if y has a coefficient as well? Okay. What you do is you always isolate the one variable, and all that happens is the equation you're subbing in will have a fractional part. But again, it's all about building. What you can do is I'm doing another lesson after this with another group. And if you watch the last 20 minutes of that lesson, you might be able to see an equation of like that, because that class goes a little bit faster. But I think it's also a balancing act between going too fast and confusing yourself and building up slowly. Okay, cheers everyone. I hope you enjoyed today, and thank you to Lebo for all your help.